All right, so what if we wanted to examine um, some predictors of time to an event or adjust for covariance or confounding variables? We can use what's called Cox proportional hazard regression or Cox regression analysis. And it's used to examine the effects of several predictor variables on survival time, which in this case is our outcome variable or our dependent variable, while adjusting for those confounders. The nice thing is it reports the hazard ratios with the confidence intervals. So it's very similar to logistic regression, which logistic regression report you can it will commonly report odds ratios for you, or you can calculate that from your beta coefficients. Some of the key things, just for your familiarity when you're doing these, just like with logistic regression or another regression analysis, is that sample sizes can be an issue. As many times you need large sample sizes to account for the number of predictors. So reliable results, the number of events needs to be high enough that you can actually model that time to event. So meaning if you're looking at a study, a cancer trial, and you're looking at death as the time to event, and the event of interest is death, unfortunately you need enough people to die so you can model that outcome. So the rule of thumb is one variable for every 10 events. So if you have 10 variables included in your model, or 10 predictors, you would need at least 100 cases of death, which means you're probably going to need a fairly large sample size. So say you have a 10% overall rate of death, you need a large sample size to be able to calculate if you had 10 variables. So one of the articles that I've included for your reference on Blackboard, and I encourage you to read over it, at least read it in the context of looking and trying to understand the survival analysis and how they came up with this. Other than the fact, I think it's a really good article on sleep apnea and mortality. But this is showing you here a representation where they did some Cox regression analysis, and they have different groups right here where they had look at the apnea-hypopnea index, and they're comparing OSA survival rates of patients with OSA based on OSA severity. So no OSA, mild, moderate, and you can see they're all pretty close. So without even looking at the statistical test, you can see you've got to question whether there's any significant differences between them. However, the mortality here with somebody with severe OSA, in this case untreated, was significantly lower at 15 years. So here, if we look at data from this particular study, they have it if you want to reference the article. Review it. It's table 6, and so here they have mortality risk with untreated, what they call sleep disordered breathing or OSA, and they followed almost 1,400 patients. Here they have their baseline OSA severity, and then they looked at differences in all-cause mortality, meaning they died from anything. And then they categorized them in just by cardiovascular mortality. Say they had an MI. Now, all of these hazard ratios, like with logistic regression, they're comparing them to a reference group. In this case, this is to the group that had no OSA. So one of the things we look at, let's just look at the all-cause mortality. All right. So if they had mild OSA, the hazard ratio is 1.4, so 40% higher risk of mortality. However, it includes 1, so it's not significant. Here, about a 70% increase in mortality with moderate OSA compared to no OSA. But there again, it's not significant. Now let's look at severe OSA. That's a 280% increase in the risk of death when compared to no OSA, but it was statistically significant. Now, one of the things we can also say is that it's not a very precise measure because the hazard ratio goes from 1.6 up to 9. And they did show a significant trend there. Now, what they did is these hazard ratios are adjusted for age squared, which you'd have to read the article to figure out what that means, gender, BMI, and BMI squared. So I'm not exactly sure what those meant. They also show here that of these 1,400, 126 patients reported usual use of CPAP, meaning they were compliant with CPAP therapy based on this definition. Now, if we look at cardiovascular mortality, we see the same trend. Not significant, not significant. Oh, this is significant, but that's a very large confidence interval, so we're not very precise. So you may need to question the results a little bit, even though it was statistically significant. Now, if we look over here, now they truncated this just at 50% to make it a little bit easier, I guess, to read. And same thing we're looking at. And what they show here is there was a statistically significant differences. And so this is only looking at untreated OSA patients. And what we did see was there was a significant difference between the groups. And we can even tell by looking at that this group was significantly higher rate of mortality compared to these other groups. And there was actually no difference between these groups in mortality, only this group with the others. And what we show here, which OSA group had the significant hazard ratios, is what we just talked about. And we also said how much higher risk, 280% higher with untreated severe OSA compared to those without OSA. So that's how you would write, if you're reading an article, that's one of the ways that they should be able to interpret those results. So in conclusion, survival analysis is used when we're analyzing time to an event. And we use it because we don't use multiple regression analysis because multiple regression doesn't do a very good job of handling censored data. The Kaplan-Meier methods estimate survival using what's called conditional probability, where the probability of survival is based on the previous time frame probability. It's a product of those. And you can use a log rank test to compare survival curves between two groups, like we did with a saline bolus study. And the hazard ratio is the risk of an event compared to a reference group. And we can use Cox regression analysis for prediction of time to an event based on a set of predictors, and it allows us to adjust those hazard ratios based on those confounding variables. So if you have any questions, please contact us.